Um, first off, I just want to thank everybody for the spirited discussions. We were discussing and trying to synthesize in that room, and it's interesting to see, how diverse the conversations that were had in each breakout group were. So, thanks for putting a lot of these ideas on the board. It did make it a bit tough to synthesize, as well by the end of it, but I think we tried to come up with a way of structuring everything that you mentioned, back to you. And I would say that our discussion kind of fell around three themes that we talked about. The first was, the motivations around such a collaboration in the first place. People came at it from very different directions. Some focused on sovereign AI, some focused on shared scientific standards, some focused on, how you extend to industry. I missed one of those. No, nailed it. All right, super. And then, from there, even though we come at it from different motivations, those motivations do drive where we would actually find the scope of collaboration. And there were, again, tons of different suggestions. I'll let kind of the others summarize what were the most salient ones in their rooms, but in our room, there was, quite a focus on, one, shared lobbying is what I would call it. Ultimately, the fact that many efforts globally, at least for open models, are sometimes stymied by what the regulations are in different ecosystems. And the fact that when you translate between development environments, those regulations can change as well. And perhaps, rather than only going to the one place that, allows for the most permissive type of AI development, which was Thomas's suggestion, we should all move to Japan. It might be better for us to actually try to have a communal lobbying effort to perhaps change or, at least get some exemptions for some of the regulations that exist. There's also a big discussion which related back to a presentation we saw today around what could be kind of a shared scientific, reporting requirement, such that, the information that we get from the experiments that we run can be kind of translated equivalently across different development environments, as opposed to, right now where it can be a bit chaotic to try to understand what everybody did, and where we're essentially always, trying to interpret a bit what is reported in reports, where there's lack of negative results that are often reported. And so, a lot of times negative results are reported more in back channel Slack conversations, as opposed to in the artifacts that are actually produced. So maybe there could be, if there were kind of a shared scientific reporting framework that goes beyond what our academic systems currently provide, that could allow people to be a lot more effective. I guess the way that I sort of synthesize this is, how do we lower the cost of collaboration and communication across different groups, even as we acknowledge that there needs to be a bit of competition between them to drive kind of everybody to engage as strongly as possible. And I guess, do you want to add any more dimensions?
I can take some of the ideas I got in our conversation. So one of the things that I think was interesting for me was the idea that, what is needed most now is still the state-of-the-art model. That's the key artifact to move forward. Even if, agentic might be a thing, this is, what we have to get first. And that probably to get that done practically, it's actually a very small team that drives the effort, decides the effort, even though it's supported by a much larger team that can take part of various aspects like data preparations and ablations before. But the decision must be taken in a very focused manner. Then the other thing that I thought was interesting, and so it's partly personal preferences that I'm using here, is this question on sovereign AI. I brought up that cannot be a model per country or even the EU, but maybe the idea of the NATO that has a shared goal and shared values with as a goal to deliver this kind of artifact might also work for these state-of-the-art models.
Yeah. I guess something that came up that adds to what Antoine said was that this trying to change a bit the communication culture, which right now happens mostly through the sort of established academic channels with papers being published, which often lack negative results, and to also reduce the time it takes for this conversation to happen, that there might be something like a shared space that people from different model builder initiatives can go and exchange information beyond such that these physical meetings. Also, there is this aspect of our community that everyone is sort of sharing some code base as well. And often that sort of code base is suited very much to their needs, but sometimes lacks additional effort to really become a product such that it can be adopted by these other members of the community. And one idea there was is that if there is a sort of a consortium that already maybe lobbies for AI rights, that they also have certain engineers or so to identify open source software packages that are promising and in need, and help to push them really towards, let's say, an industry standard that then also makes it easy to adopt with maybe mini courses or educational material documentation on top of just the actual code, and that it not just works for this one group, but actually works for all the other groups as well. Yes. Maybe I'll just hand over the ball to Valentina, figuratively speaking, and I'll have something more to add afterwards.
Yeah, so one thing we discussed was that it would be super useful to have shared user prompts, actual real user feedback, and maybe in terms of, for example, an AI factory where open models are launched and then this feedback is being collected. We also discussed that generally it's easier to share codes compared to data. Yeah, I think those.
Along those lines, there was a bit of a discussion as well in our group on where do we draw the line. And so we have a certain standard when it comes to the artifacts that we want to build. We sort of agreed that they should be scientific and reproducible, and usable as well. There's different ways of how to understand this, but mostly that someone can then take this and can either do research on it or actually can use it to build a product or service. But we need to think a bit more deeper about how is the model then going to end up in a product or something like this. Like in the Linux Foundation, they focus on building the kernels, but they got a lot of funding from now I forgot the name, Red Hat, that essentially would use the kernel to then build software products that are then tailored to particular use cases. And this sort of industry partner is kind of missing at this point. And this would be interesting to sort of foster, to then also get that feedback loop with these potential users to drive the adoption of the models. And this then also comes with additional questions in how these models are served. And I think there's a lot of compute that is coming to be that there's going to be around for serving models through some of these AI factories, which are dedicating part of their resources specifically for serving for companies. But this is also something that can be much more decentralized and in the future likely will actually rely on different hardware than the hardware that we train on. And so I think keeping this in mind, trying to think about how we can move towards such a solution where there are actually industry partners that adopt these models, that is something I think we should try to explore.
So one thing that as model developers, right, one thing that really is a huge pain point is based on the trends that we see in in Gemini and DeepSeek and all those other closed models or open weights models, is that RL is very important. Distillation is very important, right? But other than, well, there's only a few open source frameworks out there that exist, and we know for sure all the private companies have stuff that's way better, but they're never going to release it, right? So if there is a way to really pull together what we know and really optimize certain distillation frameworks or RL frameworks, because we know that there's a lot out there in research papers, right? But if you can have something that is more optimal, right? I think that could be a big part of what makes this idea of having like an AI factory more appealing, in a sense. that we don't have to waste so much compute trying to figure out like what's a good way to do RL, right? If you have something that people can test together, I think maybe that's too ideal, but I think that would be nice.
I think this is mostly a systems question, even, and less of like an AI question on what algorithm to run, but more like how do you do things effectively in an asynchronous way and so forth, and less about what are the environments and what is the data that you run on. Do you agree? Yes.
I think Luca.
That to like Docker, but for running environment, AI environment, like the solution there's going to be different, but having like that type of software being based on
Which is part of this, what I try to advertise that we have been working on quite a bit and you know,
So,
that we would like to push.
so how to do, Docker really means containers.
Yeah.
And that is a solved problem. So we have Red Hat with the name I'm getting tired.
The OCI hooks or
No, the OCI hooks is the part we need to provide. But
Podman. Podman.
Podman. So Podman and building an environment around Podman, and you have the container problem.
requirements
is
are,
solved.
the requirements are a little different, right? What if like every rollout has a different dependency? So you can't rely on caching, which is common, of like environment changing every time you do a new generation. So I think the primitives are solved, and it's just a question like we're arranging them the right way. But we tried all the existing tech, and it's like, this is just too slow.
Yes, and that's why you have this open container initiative. You have standards on how to create the hooks to the hardware, and so those are, I think, problems you can, that or can be are solvable. I have a question. Why is sharing data difficult, apart from the copyright problems?
So, okay, so in my group, we heard a lot about the perspective from the open weights Chinese model companies. And there they said the most valuable thing for them is the people working for them and the data, and that they can't share because that's like the thing that gives them the advantage. But they can, for example, share their GitHub repos for whatever framework they use to train. So that makes it, in terms of like economic advantage, I think that's mainly their reason. But then also, I mean, across, for example, if you're thinking of collaborations between the US and Europe, I mean, there's completely different laws in terms of, I think people in Europe can't do the same thing that we at AI2 can do. So there's also differences there.
Okay, so it's legal questions.
Well, I also understood that it was like partially the formats are not as well defined and kind of the structure, how you share, the data in a structured, understandable way that people can use and adopt it.
Training data sets, no, I mean for language, there is not really anything to figure out about the format. So it's pretty standardized language vision as well, actual language audio. So for scientific exotic data formats might be the case, but I mean, they are not available at the scale anyway, I guess, not that I know. Not aware of formatting or structure problems in sharing.
It depends, right? So for us, like we care about multilinguality, right? So we format or we pre-process the data in a certain way, but the way that we've done it may then be less valuable for other people, right? I guess it's a bit more like that.
Yeah, I mean, I think it also just comes from the fact that one of the big advantages of open data is ultimately for scientific purposes. And, getting the value out of that data for scientific purposes is just about having the data, its understanding in what order the model has ingested it exactly to reach the capabilities level that it was finally at. So it's slightly more complex than just sharing the data for scientific purposes. You almost need to share the exact parameters of the data loading. You need to share at what point the data mixture may have been changed halfway through, at what iteration. It's an entire it's an entire attribution chain that needs to be shared in order for it to be exactly replicated across that very large.
So why is that hard? I mean, you just provide the pipelines that belong to the whole story of data handling up to the trainable data set and whatever phase you use the trainable data set on.
Well, I mean,
Like
you
this
still need to be, you
again.
still need essentially to be able to give the exact same data loader with the exact same random seeds with the exact
This
same
is
order
not
of
that
batches.
sensitive. I mean,
So the,
I mean, it's sort of reproducibility.
I guess
no,
But it will
I
converge.
think what you're saying is absolutely understandable. There is software engineering that needs to be somehow shared here, not just open source software. You can throw out open source software and most of it is useless. It's the underlying engineering, the process, etc. I agree that is takes an effort and is, but those are problems that should be solvable. The challenge is with the copyright laws, and the copyright laws will somehow adapt. And
They
change.
also, even in the case of complicated case of language vision, which clients suffer through, if you provide just the metadata for the data that you would like to compose to the data set and the pipelines necessary to get the metadata to download and to get the data set finally complete, you have like thousands of works that use it, so it's reproducible. You see that people actually use those pipelines to get the data set composed, although it's difficult. So once you get this part straight, that you have the whole processing tooling together with the data sources that are necessary to get the final thing, the data set composition done, it becomes a community thing that is useful. So it's
yes, but managing community software, I know you know how to do it in Jülich much better than anybody else. I tell you from personal experience, is not trivial.
Right.
And we need to work on that. You need the scalable, the management processes to do this, to scale agile processes, etc. And at least for us pedestrians, it's not trivial.
To add just a quick comment, it's not just about the pipelines to actually do that, but actually to prepare the pre-training data as much as possible, because we have already a Hugging Face where a lot of these data sets are hosted, but one of the difficulties is to annotate this data, to filter it, or at least annotate it by quality such that it can be easily filtered, and then model builders have less of an effort in trying to build a software stack around what data should be used. And I want to also juxtapose this a bit with the software that's sort of needed on the systems side of it, right? Because once the model is trained, the model should also be made useful in a way using tools or a system in which the model is embedded such that it can actually be served to users in an easy way, and also to researchers to explore this model. And it would be a bit of a pity if every organization will then also build their own CLI interface and whatever. And these are all things that we actually could come together to find one solution. But it seems like then there needs to be maybe even like a sort of a centralized organization, or at least a very well managed, distributed effort that the individual communities agree to contribute to.
So can you imagine in all this software, open source software world, there is, we know, the Linux Foundation. And we have, thanks to the exascale computing project that, DOE ran for a few, almost 10 years, they created this high performance software foundation, which is governed in the context of the Linux Foundation. Can you imagine creating an LLM or software infrastructure part within this high performance software foundation and potentially release models either under that, or it could even, because we have Apache too, we could be also under the governance of the Apache Foundation.
I don't have the answer to it, but I think you also mentioned releasing models, right? That would also imply training and all the issues of getting compute and such. That I'm not so sure about, but just thinking about the pipelines that everyone needs anyway, and potentially including also the data, that I think I could imagine.
I think Luca had a comment.
Yeah, no, as like one of the things that I think our discussion group, first if the discussion groups have the same first split is a lot of the questions were around pre-training. But if you look at a place where there's the biggest gap to commercial player, I think it's on the RL side. Like, you know, the data we can discuss what's the right format. I think it's like everyone seems like a path to like, oh, this is how you standardize it. And I'm much more concerned with like RL environment, maybe with like, oh, it has tool use, and during you know, RL training, it has access to search and can use this tool. And I'm like, that, how do you share that one, you know, standardize it, have like a good baseline that we can reuse? That it's a lot of components where like, I don't think there's been enough thought around like, what are the standards, what are primitives that we share that versus data. I don't know, like, someone likes Parquet, someone likes to play JSON files, someone has their favorite format, but it's like, you can convert from one to the other, like, the path is kind of clear, but I don't know if that was discussed.
The interesting part is that actually relies very much on HPC facilities to be prepared for such tooling. So Podman was now coming up. And then if you talk to facilities, on the very few of them at all are ready to deal with Podman. So they say it's like virtually impossible.
But it's actually much larger.
Why it's impossible? So that it has to be a coordinated action that also then talks to the facility. Because look, all right, tooling is important. Yeah.
So discussing Podman, the thing there is most of 10 years ago, all this container stuff was new in 2016, 15, 16. And then most HPC facilities just bought into Singularity, okay, because that came out of Livermore, and there was a company that was supporting this. And but Podman now came out as the winning solution in this open source area, so it isn't, like I said before, it's a solved problem. It's just a question that the facilities need to invest in.
Sorry, to give you this.
And now you can ask, why did we not succeed?
Yeah.
Getting Jülich to adopt Podman? Let's talk about this over a bit.
All the time.
I can document it in writing everything. So the problem there is more like there is a culture in these centers, and you need to change that culture.
That's a long story.
No,
I'm curious to hear what Lucas has to say.
Learn that containers are sold. That's great. Very happy about it. But people have been trying for 30 years to create like an open alternative to Google search. And the folks at CMU tried, and Common Colors tried, and I'm like, if search is one of the two primitives that at least the current generation models have, search and code execution, I'm like, is that part never going to be like open source? Are we all going to have our own API service, or like, is that like it's core? Like this environments they need access to and minimum code execution tools and search tools. Maybe we'll solve one of it, but the other one is like,
It's a good remark. I think this is one of the next challenges.
I think we should not try to reinvent the things that can be solved, but learn how they are solved.
Search.
And I don't know yet.
yeah, that's scary that many have tried and it's repeatedly failed. Very non-commercial, like viable search engine.
There are some industry actors right now who are seeing that there is this need now, especially for this agentic future, that are starting to build this sort of search engine more specific for that need. I do think that there will be a solution on the horizon eventually in some way that is feasible, I would say.
But you might still be behind an API though.
I mean, what we were, I think, discussing more is like not just the containerization, but actually, the actual engine that is doing the pre-training and the post-training. And you can, to some extent, even combine these two, because you could imagine pre-training in the future to be a bit more adaptive, where you select what sort of data to train on based on evaluations that you did during training, which then is not maybe so different from RL with verifiable rewards, where you synthetically generate that data instead of selecting. But anyway, figuring out what that engine looks like and making sure this engine runs efficiently is quite a tricky endeavor on its own, and it would be a pity if everyone sort of is reproducing that on themselves. And so trying to merge that effort, that would be great, I think, because in the end, what exactly are the details of the model and what is the data and what are the environments? These are things that are then more idiosyncratic, depending on the individual needs and the culture that or the company, the area that is behind it. But the main core, the motor is always going to be the same.
Can I then maybe give another example from my original field in materials? You have organizations like SICAM, which is the European Center for Atomistic and Material Simulation. I've forgotten the name. And they have workshops where they come together, different groups, and actually work on software and jointly move their field forward. Is that something that is actually something that would help this community more, instead of having these loose calls for collaboration? Have the center, European International Center, that actually hosts workshops, hosts efforts, leads to white papers that
I think if they focus on producing the software needed to do the actual training, the command line interface, the system part of it, maybe also or in particular, the pre-training engine I was talking to, also evaluations, for example, in a way that really every model builder would want to adopt, I think that would be quite valuable.
And that they don't do, they just bring these people together and give them a space and environment to do that.
But even discussion.
Well, the scope, I think you can define.
Yeah.
The CECAM, Centre Européen du Calcul Atomique et Moléculaire. They exist since the 70s, are one of these European institutions before the EU, with a very strong, scalable governments, etc. I think the scope of what they do can be adapted. It's more the question we need to study, like ECMWF, the governance they have.
I think like at this stage, like a good forum to discuss like even high level design. It's like from our experience at AI2, we have a very different philosophy around like the trainers. Like if anything, we're like splitting more and more the components. So there's like the execution engine for training, the execution engine for inference, and then there's the pre-training code that use it. Like now our post-training uses the same execution engine, the pre-training. So like we've been separating in the components. It might be the wrong way to approach it, but like a good place for like consortium where you can discuss design of such solution without necessarily folks who want to solve the skill in a specific way because they also solve the hardware idea would be nice.
Yeah. So I think that let me ask now, Emmanuel and Antoine, you even had relationship with AI2. Why are we not using that?
Well, sort of. I mean, not in any way, but as part of the Apatic One development, we were not directly exchanging ideas on a very close level. It's through the academic channels as usual, I would say, to the conferences and stuff like that.
Because one of my worries at the moment is, for reasons that I completely understand, because I know NVIDIA for a long time, the last 2 or 3 years, they have gone down a very narrow path in how AI systems are to be implemented. They have good reasons to do that, but this is creating a monoculture that could be wiped away by the Chinese or anybody out there who has a healthy, competing effort. And so us relying on Megatron, on nickel, baked up nickel with lip fabric interface, etc., is really a very dangerous situation to be in.
I mean, the short answer to your question is we did benchmark a few different trainers when we started, and Megatron was the one that we could get the highest throughput for with let's call it the limited resources, we had to engineer something
I
more.
think that's a very, very good point where like we're small. Each of these collaboration, they take extra effort. Cost, I don't know, 20% more to develop a software that others use versus one that you use just for yourself. 20% array. I don't know what the cost is. But at the scale that each one is, that cost is very high to bear for potential uncertain outcomes. And so it's a question of like, can you get more people in so that that cost is easy to stomach, or can you guarantee outcomes for collaboration regardless in some other way? Because otherwise, like the risk of like, oh, we agree on this thing and for no one's fault, didn't work out, it's a big penalty.
I mean, there is a foundation actually, I mean, developing some of this software, right? The PyTorch Foundation, right? I mean, it is a foundation that, like we're talking about, right? Develops this in the open, it's a foundation, like there's members, it's not European, but I think there are European members.
It's the scale is a little tipped of like
It is.
design.
I understand
Who
that,
has a voice in that design?
of course. Yeah, Meta is probably very influential, right?
I mean, even like when they had their own Torch Titan and various things,
Yeah.
like the community hears it when they decided to put it out. It's like it's not as collaborative as it could be. There are wonderful people there that
But it is handed over now to the Linux Foundation. It's
Yeah.
not under Meta's control anymore.
Yeah.
I guess they're just not really solving the problems we have at the level that we need them to be solved. I mean, Torch Titan, for example, is not intended to be a replacement for Megatron, for example. It's more considered to be a research platform for some of the questions to improve efficiency. But Megatron has features that Torch Titan doesn't have that are giving us a little bit better throughput. And it just matters at scale to be as efficient as possible. And NVIDIA is putting a lot of effort into
It would be a simple question. Can a community effort bridge the gap to Megatron and make the similar thing, replace it? So, we have open source toolkits that are doing distributed training, but if you are caring about your compute being spent in exactly the efficient manner how facility expects from you, you just measure the throughput, realize Megatron is quite better, and then you abandon alternatives and nobody develops them. Close the gap. So can community be strong enough to invest into closing the gap? Who will be these people who work full time on doing it? I mean, NVIDIA obviously is interested to push Megatron, right? Where do we sustain or where do we get the same kind of interest? If we can, then it will happen, right? And then we don't have dependency on NVIDIA anymore. But so it seems to be the motivation is somehow not there. Otherwise, it would have happened.
So what's the motivation for closing the gap though, with Megatron?
Getting rid of dependency of NVIDIA because they are of course adapting their stuff towards one accelerator. So if you have then different accelerator, then have fun. So I mean, people on AMD machines have way more fun than people on.
I think the conversation evolved a little bit because initially the idea was not just to replace Megatron, but to think about other pieces of software that we care about, like evaluation or data processing at scale. I mean, for example, been using some of the libraries that Hugging Face developed, which is great, but it's one thing to just continue developing those code bases that everyone needs anyway. But the other thing also to then, for example, process data with it and make data available. So it's about trying to put together efforts that everyone would have to do on their own anyway, and trying to benefit from each other.
Megatron is one piece covering one piece of a pie.
I wouldn't want this organization to replace Megatron anytime soon because Megatron is not so bad, and NVIDIA is actually listening to the community as well to a certain degree and improving things. But like work towards like these other pieces, like for example, reinforcement learning at scale with lots of different environments, such that we have one engine and then we could in a distributed setting like have 1,000 people work on 1,000 different environments, and then a model developer can just use that engine and pick the environments they care about that work the best in order to then do the training run that they want, and everyone can do their own thing. But this currently does not exist.
Yeah, maybe two final comments.
Nico as well.
At least what I heard during our conversation was that yes, we should be using shared infrastructure, but that's not necessarily the end goal. The end goal is we all want to catch up with the closed source frontier, right? We're all too small to do that ourselves. So we need to somehow collaborate efforts, in some sense, build on top of each other's efforts so that we become a coherent family of models that is accelerating faster. In the service of that, we want to be able to use shared infrastructure that helps us realize that vision. So it can be an imatron, it can be evaluation, tooling. The point is we get to that vision as opposed to getting hung up on specific tools. And the tools that emerge, I think they will emerge. There will be opportunities for us to build useful things as an open source community.
I was wondering, Emmanuel, how realistic do you think it is that basically we get a bunch of academics and scientists to do lots and lots of software?
I mean, I don't think this can be done by academics. At least not like PhD students and postdocs level academics. It needs to be dedicated engineers that are building this expertise and know what researchers want, but can fully commit to this without having to teach, write papers.
I think it's great. I think the goal is great, but I wouldn't even know how to contact to get funding.
Okay, so this is now an area that computational science has gone through 20 years ago. It was, we can only develop software if it's done by PhD students. And over time, and I think thanks to a lot of very early British effort, there is a new trade that developed called research software engineering today, which in the science community, you would not build any big apparatus if you don't have electrical engineers. Actually, they acknowledge it today, but glass blowers, chemical engineers that grow crystals, etc. Nothing would exist in science today without those trades. It took a few decades to get the computational science community to realize we need something equivalent, and that's these RSEs today. And I think the community as it develops can develop a funding model. And this is not just the funding agencies, it's also the scientists that need to acknowledge that a certain craft is needed. And I think it's communities like what I heard today that can create this for these open models.
Maybe this is a hot take, but it's like, I don't think any researcher who is not willing to put the engineering in should be in the business of building LLMs. Like this is very much like a system craft, like the research goes with engineering. You're not going to answer a research question. You can put an engineer. You don't have bandwidth to do the engineering.
And the worst,
work on some of the things.
The worst people there are can be mathematicians or mathematical physicists also who have lived in a different universe for the past few centuries. They kind of destroy this sort. But any scientist will agree, you don't build an experiment without people who invest time in engineering. And so you're absolutely right. But in academia, we have a culture of, we prefer the Einsteins over the.
I totally get it. I totally get it. The reality is you can download some tool from Hugging Face, some data set from Hugging Face, you do some science on it, and you can get a paper published. And then you have the choice, and then you can get that in a short amount of time. I fully agree also with you regarding the requirements for model builders and scientists, but this is just that it's just so much lower threshold. And then I tell them, hey, you have to work 1 year on software, on some post-training framework for Europe. Then you maybe get one paper out of it at the end of the day.
I can give our small reality IQ, which is we changed. Now that we're doing OMO, we changed quite a bit of recruiting for intern, where we specifically try to attract interns who are willing to put the large effort that were software effort required to test ideas at scale. And it's not for everyone, but you find that people are that style of research excites me. So maybe
What made them join?
I think it's just that they like to do high performance computing at scale. They're not satisfied saying, I test this idea in a total setting. I want to test it in the largest possible setup environment, experimental thing. I can. The more risky, if you test it at scale, the more expensive it is, the more they get excited. I get excited, so I get it.
But was Olmo as a brand also helping?
Maybe, but it's communicating this honestly to like people that's like.
Where do they get jobs afterwards once they are?
Oh, they have such a long line from all different
Yeah,
here.
exactly. I think that's it. That's the point, that in some countries, not necessarily many European countries, but definitely in the US, these people end up making much more money than any professor with each factor of 100.
Yeah.
And on this note.
I would want to just quickly push back a little bit on the hot take, because I think there's a lot of people who care about the capabilities of the model, and then they think much more about data distributions and ablations, and they don't necessarily care if they were what they need to do in order to get performance a bit 5% higher throughput or so.
Oh, sorry. So debate to me that's the whole set, right? If you're doing the software to like filter the data and you want to make things like you do a good open source software so the next scientist can use it, that still counts as infra. Like it's not necessarily like the model going faster, it's across the entire pipeline.
Okay.
I have a question to the audience. Can part of this discussion continue with a glass of wine in the hand, or is it mandatory to sit here?
Thank you everybody for joining this discussion.